The 2020 National Electrical Code does not explicitly prohibit the installation of switched plugs on dimmers. However, there are several code requirements that may apply. Article 404.2 covers dimmers. Dimmers must be installed in accordance with the manufacturer's instructions. Article 406.4 covers receptacles. Receptacles must be installed in accordance with the manufacturer's ratings and must not be overloaded. The manufacturer's instructions for both the dimmer and the receptacle should be carefully reviewed. Some dimmers may not be compatible with all types of receptacles or loads. Plugging high wattage lamps or other appliances into a switched plug on a dimmer can create an overloading condition, especially if the dimmer is not rated for the load. This can cause overheating and fire hazards. Dimming a switched plug can make it difficult to identify when the plug is on or off, creating a potential electrical hazard. The use of plug-in adapters or extension cords with dimmers can further increase the risk of overloading. While it may not be explicitly prohibited by code, it is generally not recommended to install switched plugs on dimmers. This is due to potential safety concerns and because it may not be compliant with manufacturer's instructions or national electrical code requirements. If the homeowner insists on having switched plugs on dimmers, it is crucial to firstly, use dimmers that are specifically rated for the load, secondly, ensure that the receptacle is also rated for the load, and thirdly, avoid overloading the circuit. Consider using other methods for controlling plugged-in devices, such as a smart plug or a timer. Let's delve a little deeper into the specifics of these considerations. When selecting dimmers, it's not just about aesthetics or convenience. Dimmers are designed with specific load ratings in mind. This rating, usually expressed in watts, dictates the maximum amount of power the dimmer can handle safely. Exceeding this rating can lead to overheating, damage to the dimmer itself, and even pose a fire hazard. Therefore, it's crucial to accurately assess the wattage of the lamps or appliances that will be connected to the switched plug. For instance, if you plan to use a dimmer with a rating of 600 watts, ensure that the total wattage of the connected devices does not exceed this limit. Remember to consider the inrush current, which is the initial surge of current that some devices draw when they are first turned on. This inrush current can be significantly higher than the device's steady-state wattage, potentially overloading the dimmer even if the steady-state wattage is within the dimmer's rating. Moving on to receptacles, these too have their own set of ratings. The receptacle's amperage rating indicates the maximum amount of current it can safely handle. It's essential to choose a receptacle with an amperage rating that is suitable for the circuit it's connected to. In residential wiring, receptacles are typically rated for 15 amps or 20 amps. If you're dealing with a circuit that's protected by a 20 amp breaker, you should use a 20 amp receptacle. Furthermore, consider the type of devices that will be plugged into the receptacle. Some appliances, such as refrigerators or power tools, may require a heavy-duty receptacle that's designed to withstand frequent use and higher current loads. Overloading a circuit is a serious safety hazard that can lead to overheating, trip breakers, and even electrical fires. A circuit's load is determined by the total wattage of all the devices connected to it. To calculate the load, simply add up the wattage of each device. If the total wattage exceeds the circuit's capacity, you're overloading it. For example, a 15 amp circuit at 120 volts has a capacity of 1800 watts. If you connect devices with a total wattage exceeding 1800 watts to this circuit, you're overloading it. To prevent overloading, distribute the load across multiple circuits or use devices with lower wattage ratings. Smart plugs offer a modern and convenient alternative to traditional dimmers. These devices plug into existing receptacles and allow you to control the plugged-in devices remotely using a smartphone or voice assistant. Smart plugs often come with features such as dimming, scheduling, and energy monitoring. They can also be integrated with other smart home devices to create automated lighting scenes. Timers provide another option for controlling plugged-in devices. These devices can be programmed to turn devices on and off at specific times of the day. Timers are particularly useful for controlling lighting fixtures such as lamps or holiday lights. They can also be used to automate other appliances such as coffee makers or slow cookers. Timers are available in a variety of styles, including mechanical timers, digital timers, and smart timers that can be controlled remotely. In addition to the National Electrical Code, it's important to consult local building codes and regulations. Local codes may have additional requirements or restrictions regarding the installation of electrical devices, including dimmers and receptacles. Always obtain the necessary permits before starting any electrical work. Working with electricity can be dangerous if not done properly. If you're not comfortable performing electrical work yourself, it's best to hire a qualified electrician. A licensed electrician has the knowledge, skills, and experience to ensure that the work is done safely and in accordance with all applicable codes. They can also help you select the right dimmers, receptacles, and other electrical components for your specific needs. When dealing with electrical wiring, always take the necessary safety precautions. Firstly, turn off the power to the circuit you're working on at the breaker box. Secondly, use insulated tools to prevent electric shock. Thirdly, never work on electrical wiring in wet or damp conditions. Fourthly, double-check your work to ensure that all connections are tight and secure. Fifthly, if you are unsure about anything, consult a qualified electrician. Let's explore the NEC articles mentioned in more detail. Article 404.2 focuses specifically on dimmers. It mandates that dimmers must be installed according to the manufacturer's instructions. This seemingly simple statement carries significant weight. Manufacturers design their dimmers to operate within specific parameters, and deviating from these instructions can lead to malfunctions, reduced lifespan, or even safety hazards. The instructions often detail the acceptable voltage range, the type of wiring required, and any specific mounting requirements. Ignoring these instructions can void the warranty and increase the risk of electrical problems. Article 406.4 deals with receptacles, commonly known as outlets. This article emphasizes that receptacles must be installed according to their manufacturer's ratings. Each receptacle is designed to handle a specific amount of current, measured in amps. Overloading a receptacle by plugging in devices that draw more current than it's rated for can cause overheating, damage to the receptacle, and potentially a fire. Furthermore, Article 406.4 also addresses the proper mounting and support of receptacles. They must be securely fastened to the wall or surface to prevent them from becoming loose or damaged. The article also outlines requirements for tamper-resistant receptacles in certain locations, such as homes with young children. Dimmers come in various types, each with its own advantages and disadvantages. Firstly, incandescent dimmers are the most basic type and are designed for use with incandescent bulbs. They work by reducing the voltage supplied to the bulb, which in turn reduces its brightness. However, incandescent dimmers are not compatible with LED or compact fluorescent bulbs. Secondly, LED dimmers are specifically designed for use with LED bulbs. They use more sophisticated circuitry to control the brightness of LED without causing flickering or other problems. LED dimmers are more expensive than incandescent dimmers, but they offer better performance and energy efficiency. Thirdly, smart dimmers can be controlled remotely using a smartphone or voice assistant. They offer features such as dimming, scheduling, and energy monitoring. Smart dimmers can be integrated with other smart home devices to create automated lighting scenes. When selecting a dimmer, consider the type of bulbs you'll be using, the desired level of control, and your budget. Receptacles also come in different types. Firstly, standard receptacles are the most common type and are used for general-purpose applications. They typically have 2 or 3 slots for plugging in devices. Secondly, ground fault circuit interrupter receptacles are designed to protect against electrical shock. They are required in wet or damp locations, such as bathrooms and kitchen. Thirdly, arc fault circuit interrupter receptacles are designed to protect against electrical fires. They are required in bedrooms and other areas where electrical cords are likely to be damaged. Fourthly, USB receptacles have built-in USB ports for charging smartphones, tablets, and other devices. When selecting a receptacle, consider the location where it will be installed, the types of devices that will be plugged into it, and any safety requirements. Remember that the National Electrical Code is a comprehensive set of guidelines designed to ensure electrical safety. It's not just a set of rules to be followed, but a resource that provides valuable information on best practices for electrical installations. Staying informed about the latest code updates and changes is crucial for anyone working with electricity. Regular training and continuing education can help you stay up to date on the latest requirements and technologies. In addition to the code itself, many organizations offer resources and training programs for electricians and other electrical professionals. These resources can help you understand the code, apply it correctly, and stay safe on the job. Understanding the principles of electrical circuits is essential for safe and effective electrical work. Firstly, Ohm's law describes the relationship between voltage, current, and resistance in an electrical circuit. It states that voltage equals current times resistance. Secondly, Kirchhoff's laws describe the flow of current and voltage in complex circuits. Kirchhoff's current law states that the total current entering a junction equals the total current leaving the junction. Kirchhoff's voltage law states that the sum of the voltage drops around a closed loop equals zero. Thirdly, power is the rate at which electrical energy is transferred. It is calculated by multiplying voltage by current. Understanding these basic principles will help you troubleshoot electrical problems, design safe circuits, and comply with the National Electrical Code. Finally, always remember that safety is the top priority when working with electricity. Take the time to plan your work carefully, use the right tools and equipment, and follow all safety precautions. If you're ever unsure about something, consult a qualified electrician.